The last thing we're going to look at today is something called the common ion effect. So the common ion effect, what does that mean? If a chemical is added to a reaction at equilibrium, and that chemical has an ion in common with the reaction, equilibrium will be disturbed. Let's check this guy out. If we have this reaction, we've got some lead chloride going back and forth between the solid state and aqueous lead and chloride ions. If you added aqueous sodium chloride to the reaction above, it asks you what would happen. And at first glance, you might think, there's no sodium chloride in my reaction. That doesn't add anything to the left-hand side or right-hand side. What impact would that have? However, if you think about what aqueous sodium chloride means, if it's aqueous, that means it's dissolved in water. It means it's broken up into ions. So when we put aqueous sodium chloride in there, we would make the sodium ion concentration go up. We'd make the chloride ion concentration go up. Well, yeah, we're making the sodium ion concentration go up, but quite frankly, we don't really care about that because there's no sodium ions in our reaction. However, the chloride from the sodium chloride has something in common with this guy up here. We have an ion in common between the chemical that we're adding and our reaction that's at equilibrium. And the reaction doesn't know that the chloride came from sodium chloride instead of lead chloride. It just knows that we have extra chloride in there. So our stress is that we make the chloride concentration go up. Well, if we have extra chloride in there, we need to shift to the left to try and fix ourselves. If we're shifting to the left, our lead ion concentration is going to go down. And it would be inappropriate for me to say the PbCl2 concentration goes up because it's a solid. So we wouldn't have the concentration go up because you don't have concentrations. However, you would see more precipitate forming if you dumped in that extra chloride. If we have this reaction here with the ammonia reacting with water to make NH4 plus and OH minus, I'm going to throw in some states of matter here. Sorry guys, I forgot to put them in before I printed this for you. So we've got aqueous ammonia and liquid water reacting to make ammonium ions and hydroxide ions. So if we added aqueous potassium hydroxide, well, potassium ions would increase, hydroxide ions would increase, but we don't really care about the potassium ions because they're not in our reaction. Our hydroxide ions are. We have an ion in common, so this would impact our reaction. So our stress is we're making our hydroxide ion concentration increase. So the reaction tries to fix itself. The right-hand side got too heavy. We need to shift to the left. So if we're shifting left, our ammonia concentration is going to increase. Nothing happens to the water because that's a pure liquid, so you can't increase the molarity of a pure liquid. Our hydroxide ion concentration would decrease because we're moving away from it.